Hi ladies and gentlemen, this is Mr. Green. This is another in my series of lessons on pre-cal. We're looking at Unit 2 and we are doing graphing of trig functions. Just a note about due dates, don't let things go beyond 28 days because you let them go beyond that 28-day mark and the zeros get locked in, can't reopen them. You want to make certain you get them completed, okay? So where are we at? We are looking at stretches, shifts, and flips. Oh my, stretches, flips, and shifts and flips. That sounds like a quote from The Wizard of Oz. Oh my. So, when you're looking at a function, f of x, you recognize that if we put values in the function here, these different values here, it's going to cause the function to do different things. If we put an a or a value here constant in front of a sine function, it's going to multiply all the values that you've got for this. So instead of going up to 1, it's going to go up to a. And instead of going down to -1, it's going to go down to -a. But we add this additional shifter in here. This one here. This one will actually cause a little bit of shifting too, a little bit of stretching too. It will cause it to be up and down a little bit, but it actually causes the frequency to occur more frequent inside of a 2 pi range. So it'll actually cause it to double up in there. Okay? This value here will actually move it to the right and left. So if it's a positive number, it moves it to the right. If it's a negative number, it moves it to the positive to the, I'm sorry, yeah, to the right. If it's positive, to the left. If it's negative. Okay? That makes sense? I hope so. That's going to be where we're actually shifting the graph right or left a little bit. This one causes it to move it up and down a little bit. Let me give you some examples of this. Maybe it'll help you see it a little bit. If we want to move the sign from starting at 0, 0, we want to move it up to starting at pi over 2, we can just add a pi over 2 at the end of it down here. And that sign is the value you get for sine plus pi over 2, and it would move it up. Let's go back and look at this. That's what I'm doing here, is I'm adding something to the end of it, and it's causing it to move up a little bit. Okay? So what would that look like? Let me just do you a quick little sketch here. We got this. This is my sine function that I've got normally, right? Okay, it repeats over and over and over again. Now, if I took this and I said I wanted to shift this up pi over 2, what are we doing? We're going up to here, and we're going up to pi over 2, and so we're doing this, like that. Okay? So what happened? We went from here at 0 to here at pi over 2. Okay? And so this point up here would be pi over 2 plus 1. This point down here would be pi over 2 minus 1. Okay? And this point here would be at pi over 2. That's shifting it up a little bit. All we're doing is adding on to the end of it. Okay? If I wanted to shift it right, and left a little bit, that's where I add inside of the parentheses there. Okay? So this, once again, is my normal sine wave like that. And if I wanted to show it shifting up by pi over 2, or shifting right or left by pi over 2, well, there's pi over 2 right there. Okay, so my graph would actually do this. Let's see, yeah, like that. And it shifted it to pi over 2. Shifted it to the right. I should have started here and done this. Okay? So okay, try that again. Shifting it to pi over 2 to the right, it would do this. Like that. Okay? So I shifted to the right pi over 2 units. Okay? That's the way that would look. Okay. if I wanted to make the sign starting at 0, 0 3 times higher, what do I mean by 3 times higher? So instead of being at 1 and at -1, I wanted it to be at 3. That'd be way up here. And I want the graph to do this, like that, like that. All I've got to do is put this 3 in front of the sine wave here. What are we doing? We're just adjusting how tall the wave is. This is called amplitude. This is exactly the way AM radio works. They adjust the amplitude of the wave, and you get different amplitudes, give you different stations that you're listening to. Okay? Not true. Let me say that again. You have a frequency that you're listening to, and they adjust this amplitude to give you the different sounds that you're listening for. Okay? Now, if I wanted to see FM radio does a slightly different thing. So instead of repeating every 2 pi, okay, they're adjusting their frequency this way, okay, so that it occurs twice in that time frame or 3 times in that time frame. It's not getting any bigger waves or anything. It just is occurring more frequently. Okay? That would be what FM radio does, is it adjusts the frequency, and that's done by putting the 3 in here. That's where we get the different numbers that we're using for the transformations. Okay? You know, if you get this, it's great. If you didn't get it, this video right here actually has lots of examples and things that you can go over and you can look at and review, and you can get a little bit better examples and a little bit more information about it. But essentially, it's just transformations that are going on there, and that's what that whole video is about. Okay? So, what can we do with this? Given a wave like this one right here, we can look at this wave and we can determine what the equation of this wave is. Now we know we've got a sine function that starts here and does this, right? Like that. That blue one is my sine function. So if I look at that and I say, well, where did it go? It looks like it shifted it, how much? It looks like it shifted it all the way to there. That looks like pi over 2. So it could be that we have a sine of x minus pi over 2. Another thing I could see here is, you know what, a cosine starts up here. It does like this. Like this. And so what we could be looking at here would be a negative cosine of x. Either one of those. You know what? That's exactly what the answers are on. So the question is, which one do you do? You know what? It's whichever one you see. Because, yes, a sine and cosine are just shifted right and left of each other. And they are, you know, if I look at a negative cosine, it is very similar to that shifted sine function. Those are very, very close to each other and something that you can use in that respect. Okay? So, looking at this one, slightly different rule here. See how my amplitude, I'm going from 3 to 1. What I'm going to do is I'm going to take 3 minus 1 over 2. That tells me I'm multiplying it by 2. So whatever it is, it's going to be 2 times some function. Okay? You see how it's going through y is equal to negative 1 right there? So what we're saying is this is a sine function that has an x minus x plus 1 because I shifted it down 1 unit. Wait a second. That's shifting the x. Sine of x plus 1 because that shifted it down 1 unit. So is it shifting at 2? No, it's shifting at 1. plus 1 at the end. So it's 2 times the sine of x plus 1 to get it to move down 1. So it's 2 times the sine of x minus 1. I forgot y's are opposite signs. Minus 1. It's not shifting on the x, it's shifting on the y-axis. Okay? That's why I put the answer there so I could check it. Okay? Hopefully you see what I'm talking about. The sign would start here and it moved it down 1 unit. That's where I'm subtracting the 1 at the end here. And it's 2 times bigger than its normal size because it goes up height of 2 and it goes down to negative 2 or 1 and 3 because of the shifter. Cool? Practice. That's what it takes. And I'm out of it. That's why I'm struggling with it a little bit here. Okay? Practice, practice, practice. If you have questions about it, come to tutoring on Tuesday, Wednesday, or Thursday. We'll do some more shifting. We'll do some more sign moving. It is a fun trick. It is something that will amaze your friends when you can do it well. Okay? So, I appreciate you telling me that you're in pre-cal every time. It really helps me identify what questions you're asking. Okay? I will talk to you later.